Welcome to our discussion on scientific notation. Scientific notation is a way of efficiently describing really, really large numbers and really, really small numbers. It's basically just a way of compressing all of those zeros down and just describing them as a power of 10. So for instance, that 5 nanoseconds, which is a decimal point with all of these zeros before the 5, can really be written as 5 times 10 to the negative 9. And then similarly, 3,600,000 joules with all those extra zeros can just be written as 3.6 times 10 to the 6th. See, so scientific notation just takes all of those zeros and compresses them down to a power of 10. The standard form of scientific notation is it's always going to be p times 10 to some power k. P is a number that's less than 10, right? So it can be a number with a decimal, and it has to be greater than or equal to 1. So it's basically anything from 1 up to 10, but less than 10, right? So it can equal 1 and it can go all the way up to 9.9. Or 999, depending on how many decimals you have. Okay, numbers that are powers of 10 are easy to write in scientific notation because we're just talking about how many zeros are is the power of 10. So 1,000 is just 10 cubed, 100 is 10 squared, and 10 is just 10 to the 1. Now, we wouldn't put the 1 there, right? Anything that's raised to the power of 1, we just leave the 1 off, and then it's just assumed that it's just itself, right? It's raised to a power of 1, so it's just itself. So when we take this, we know that it's just 3.6 times a bunch of zeros. Now, you might be thinking, well, it's 36 times 5 zeros. Yeah, but remember, we can't have 36 as our leading number. It has to be between 1 and 0. So we have to take the decimal point and move it 1, 2, 3, 4, 5, 6 places to get it to 3.6. So that's why it's 10 to the 6th. Same thing here. We take the decimal place and we move it 1, 2, 3, 4 times to get it to the right of 4. So now we can have 4 times this, or 4 times 10 to the negative 4th. So that's the other nice thing about scientific notation is it's really just how many times do we have to move the decimal point, and that tells us the power of 10. So we start with 57,400. Here's our decimal point. We know that we need it in between the 5 and the 7 because we have to have just a single digit number, right? So it always has to be snuggled up right next to the last non-zero digit. So we move it over 1, 2, 3, 4 times. So it's 5.74 times 10 to the 4th. And if we go in the other direction, same idea. We need to snuggle it up so that it just has one non-zero digit to the left of it. So 1, 2, 3 places, we get 3.8. And since we moved it 3 places, it's 10 to the negative 3. Now you might be asking yourself, yeah, but we moved it in the positive direction. Why is it negative? And in the previous one, we moved it in the negative direction, so why is it positive? Because it's positive here to tell us that we would have to move it back in the positive direction to get it back to where it is, right? To make this the same thing as this number, we would have to take 5.74 and move it 4 spaces to the right. So that's why, you get an opposite power, let's say, to the act of figuring out what it is. It's because that's what you would need to do to get back to where you were. A couple more examples, right? We got to move it 5 places, so to the 5th. We got to move this one all the way down to here, to right after the 2, the first non-zero digit, right? After all these zeros is the first non-zero digit. So we get 2.05 because it's sitting right there, and we moved it 6 places, so it's a negative 6. 47 is pretty easy. We just have to hop it once, so it's 4.7 times 10 to the 1, which we really could just write it as 4.7 times 10. Okay, when a positive number greater than or equal to 10 is written in scientific notation, the exponent is always going to be positive. And when we have a positive number that is less than 1, i.e. something that is already a decimal, then the exponent is always going to be a negative exponent. When we have a number between 1 and 10, the exponent is going to be 0 because if it's between 1 and 10, we don't have to have any powers. So to convert a number from scientific notation to decimal form, i.e. to bring it back to kind of its regular form, we're just going to shift the decimal point how many times that's indicated by the power of 10. 3.2 times 10 to the fourth means we start here and we move it 4 times to the right, because it's positives. 1, 2, 3, 4. 32,000. For the negative exponent, it starts here and it goes to the left, right? So it starts in between the 2 and the 7 and goes 1, 2, 3. So there's our 0.0027. Really simple. Don't overthink it. Positive exponents means you shift it to the right. Negative means you shift it to the left. Okay, multiplying and dividing these things is really easy because if we remember our rules of exponents, if we have a to the m times a to the n, it's a to the m plus n. We add exponents. And if we're dividing, we subtract exponents. So that tells us if we have two scientific notation things and we multiply them together, the two numbers multiply together, the two powers multiply together, and the rule tells us that we just add the powers. So a good example, if we want to multiply these two big numbers, change them into scientific notation, multiply the two numbers, right? 2.6 times 3.5, which gives us 9.1. And then 10 to the fourth times 10 to the sixth, you just add them together, you get 10 to the 10th. The only thing you have to worry about is sometimes your answer needs to be kind of like reconverted. It's bigger than 10. When dividing, you think about stacking them, and then you divide the corresponding pieces. So you take A and divide it by the C, and then you take the power of the A piece and divide it by the power of the C piece. And so you simply just take this divided by this, so you've got 4.5 is going to be divided by the 1.8. Then you're going to have 10 to the fourth divided by 10 to the negative third. You do this math, you get 2.5, and 10 to the fourth divided by 10 to the negative third means you have 4 minus a minus 3, and aha, we have to remember that when we subtract a negative, we're really adding the positive, and that becomes 10 to the seventh. Now, if the result of the calculation is not in scientific notation, then you're going to have to augment it, and this is what I mentioned before. So for instance, we have this really, really small number. We're going to divide it by the other one, right? So we have 7.2, 10 to the negative 6. We're going to divide it by 9 times 10 to the negative fourth. We stack the regular numbers and we stack the powers. We get 7.2 divided by 9, we get 0.8. 10 to the negative 6 divided by 10 to the negative 4 is 10 to the negative 6 minus a minus 4, or negative 6 plus 4, which becomes negative 2. And we do the math, we get 0.8 times 10 to the negative 2, but 0.8 is not between 1 and 10, so it's not in standard scientific notation. Instead, we need to shift this decimal point one place to the right to make it 8. And if we're going to move this decimal place one place to the right, we need to make the power one place smaller, right? We made this one bigger. We basically multiplied by 10, so we need to make this one smaller. So what we're showing here is that when we move 0.8, it's really the same thing as 8 times 10 to the negative 1. So you can see that we've added a negative power of 10, right? We've basically brought in another negative 1 power of 10. So if we're going to take this 0.8 times 10 to the negative 2 and change it to 8 times something, well, it becomes 8 times 10 to the negative 1 times 10 to the negative 2, right? Because this whole piece right here is what negative 8 is. And we combine these with the same rule of adding the exponents, and there's my negative 3. So kind of the shortcut I always tell students is, you go from 0.8 to 8. I made this bigger by a factor of 10. I basically multiplied this by a factor of 10. So to keep everything equal, I have to divide this by a factor of 10, i.e. make it 1 power smaller, so it goes further negative to negative 3. Your calculator can sometimes work with scientific notation, and it can oftentimes display things in scientific notation if you change the mode. So you could just take the two big numbers, multiply them together, and the calculator will list the answer in scientific notation. Oftentimes, most calculators I see use this one on the right, where it'll say 4.86 e to the 11th. And you're like, what the hell is e? Well, E just means that's 10 to the power of 11. E just means it's in scientific notation. So that way you can always get your answer in scientific notation easily from the calculator. Again, if you got a negative answer, it would just say e to the negative 13. Now, if you wanted to kind of multiply and divide things in your calculator, you have to learn how to use powers. And so it just depends on what button your calculator has, whether it's an EXP, or sometimes it'll just be X to the Y, or have different buttons that tells you how to make things powers. Then you have to, put it in that way and work with it that way. I think it's easier to just do most of these by hand. You could just do 6 times 4.8 in your calculator. That's pretty easy. And then realize, in case it's division, 6 divided by 4.8, get that answer in your calculator. And then go, okay, 10 to the negative 6 divided by 10 to the 7th. I remember that division is this number minus that number. So it's negative 6 minus 7 gives me negative 13. I think that's a lot easier than trying to figure out how to type it into your calculator. I would really only use the calculator when you have big numbers, or you're given the number that it is not in scientific notation. Then you can put that into your calculator and get the answer in scientific notation. And then if you have to, you can convert that back to a regular number. So here's another example. Put it in scientific notation, right? Multiply the numbers first, deal with the power, and then you get this number times 10 to the 14 lumens. And that is the last example I have for you. Hope it helped.